Assalamualaikum. Good afternoon, everyone.
Good afternoon, Doctor.
Yeah, I'm trying to. Okay, let me see. Okay, can you see my screen?
Yes, Doctor.
Yes, Doctor.
All right, good. Okay, how many of you here already? Let me see. Berapa orang dah sekarang? Alamak.
For now, we have 237, roughly 237, Dr. Fariza.
All right, okay. All right, thank you, Dr. Najihan. Okay, class, today we're going to talk more about database design. Okay, so we will be going through the PowerPoint lecture a little bit, and then maybe the rest of the time maybe you have questions, or maybe we can give you some tips on how to proceed with your design and your project. Yeah. Okay. Put this on slides. Okay, so we will talk about, actually when you talk about database design, in real life, you don't really design just the database. The database usually goes hand in hand with information system. Okay, so basically the situation is you will have an information system. Example of an information system would be the university's information system, Maya, for example, whereby you will have the information system that allows student to register, allows student to register for classes, allows for lecturer to key in marks for each student, allows for exam department to schedule exams, schedule classes, and so on, right? So that is an information system. So behind that information system is the database. And usually, if it is a new system, then the information system will be developed using the system development lifecycle or any kind of design development framework. I think you learned this in your system modeling class, right? Because SDLC is not the only framework that you can use for design, because there are other approaches such as prototyping, rapid application, and so on. But anyway, the basic is the SDLC, whereby the system development has a life cycle of its own. So in conjunction with that, usually sometimes it's being conducted parallel. You will also have the database being developed, and you have the database life cycle, also. So we will talk about the database lifecycle, DBLC. DBLC and SDLC is not too much different, okay, but there are similarities. Yeah, but it's just that for SDLC you are designing for the system, for the information system, and the DBLC you are using it for designing your database. So in this class, it is a little bit challenging, because you are only looking at the database without looking at the information system. So so then maybe sometimes when you're trying to work on your project, you will find that there are certain things that you don't really understand, because the reason that you don't really understand is because you don't have the information system to understand the process or the procedure of the organization. If you have the information system, then you can see that how does the flow of the data, how is the flow of the data, how is the flow of the processes. So maybe that would help you with the design of the database. But in this case, you only have to work with the database life cycles, so it can be a little bit challenging. So maybe you can try to think of, if I have an information system, what would the information system need? So that can probably help you to understand what kind of data that is involved with that organization. Okay, so anyway, these are some of the things that we're going to look at, including some of the common design strategy, whether it is top down or bottom up, centralized and versus decentralized design. Okay, so we start off with information system. Okay, I hope by now you already understand what information system is, because you had your information system course in this year, right? Okay, so you know that information system is a system that allows you to collect data, store the data, and then helps you to retrieve back the data so that you can get information from that data, right? So the purpose of an information system is that so that you collect all this data, because information system comes with forms that people key in, collecting the data, or maybe collecting data via scanning and so on. So this data is not going to be useful unless it is being processed and become information, right? So information system usually would get the data that has been collected and stored, retrieve those data back, and process that into a report. Now that report is the information that is being given to the user. Okay, so the information system is not only just about hardware and software, but it's also about people, the user, the people, right? And the people involve the user, the programmer, the system analyst, and so on. And in addition to that, you also have the data. So when you talk about data, then you have your data and you have your procedures. What are the procedures that allows for that data to be used? What is the processes that is being carried out, within that organization? Those are the procedures. So that is why when you want to develop your database, you need to understand the procedures, and these procedures are part of the business rules that you are going to collect when you when you do your project. Okay. All right. So information system also, in order to develop information system, you also need system analysis. This is where you try to understand what is needed for that system. Okay. And then you proceed with the system development. Okay, so when you look at information system, you want to ensure that your database design and implementation and the application design and the implementation are all being done properly, because this would affect how the system perform. Okay, and then you also need to look at the administrative procedures, such as who is allowed to access to the system, who is allowed to access to the database, who is allowed to back up the system, and so on. All right, so you need to look at all this, and then you also need to look at the database development, and this is where the course is actually focusing on. All right, just the database development. So all the thing about the information system development is in another class. You know that when you develop information system, you also need a database to go along with it. So you need to learn how to develop and design the database. So this is what the class is all about. Okay, I'll just go through this very quickly, because you should be already looking, understand what SDLC is. Yeah, because SDLC is just the process of developing the system from the beginning all the way to the end, and it is a process which is iterative. Iterative means you go from one step to the next, and then when you are at the second step and you feel that the second step is not it's not properly satisfactory, so you go back to the previous step and then add more things to it, and then so it goes iteratively until you reach the end. So if you have taken the system development, system modeling, I think it's called now, class, then you would probably have seen this. Okay, SDLC, it starts with planning, and then it goes to analysis. Then after you have done your analysis, you go to your system design. After you have completed your design, then you do your implementation, and then after you implemented the system, you don't stop there. You need to maintain your system, right? So if you look at where is the iterative part, this is where when you are planning, and then you have done part of your planning, and then you go to analysis. If you feel that the analysis is not complete, then you can go back to the planning stage and get more information. During the planning stage, you do your initial assessment, your feasibility study. I'm not going to go into that in detail because this is for another class. But you do your initial assessment, and then from there you do your feasibility study, and then you go to your analysis phase. This is where you get your proper user requirement, and then you look at the existing system, evaluate the existing system. The existing system can be a manual system, or it can be an electronic system, an electronic information system. So you look at the existing system, evaluate what are the things that needs to be improved, for example. Yeah, and then after you have done that analysis, then you do your system design, and then during a system design, this is where you go into the more detailed design. This is with SDLC, there are various tools that you can use in your system design. You do your DFD, data flow diagram, and so on. And then after you have done with the design, then you do your implementation. Implementation is actually, this is where all your coding takes place, your programming, and then your testing, your debugging, installation, fine-tuning, and so on. And then after you have implemented, then you do your maintenance, your evaluation, your maintenance, and your enhancement or your improvement. So any of this, you can just go back to the previous step and get more information so that you can do your next step better. Okay, so with information system design, you can use tools such as CASE. You can use other tools that are available. Usually in the real world, you will have a team working. So you will have a team doing the information system design, and then you will have another team looking at the database. And so the team looking at the database will proceed with the database lifecycle. So if you look at the database lifecycle, it also has its initial study, and then it has its database design, and then it has implementation and loading, and then it has testing and evaluation, operation, and then you have maintenance. So it's not too different from the SDLC. Yeah, so you start with analyzing the situation. Okay, this is what you need to do with your project. You need to analyze the company's situation. Maybe if you could actually define the problem and constraints, that would be good. But for your project, we don't really require that as much. When you say define the problem and constraints, an example would be you will say something like let's say you are looking at school database. Maybe a problem would be teachers are unable to monitor the progress of students in a systematic way. And so that would be so. So when that is the problem, then you know that your system would have to be focused on keeping track of the progress. How do you keep track of progress? That is basically more on like marks, more on their performance in terms of their quizzes, in terms of how they answer questions. So then that will be the focus of your system development or your database development. Okay, constraints may be you at the current moment you don't have the school doesn't have information or data regarding students' quizzes, for example, because quizzes is only done in class. Not quizzes. Maybe the quiz is being conducted in class by raise of hand, for example. So that is a constraint. Okay, because maybe the teachers doesn't want to make the quizzes in a very formal way, because then students would feel very stressful, because every class you have a quiz. So the quizzes are being done maybe just raise of hands. So with that type of constraint, you don't have proper data being saved. So maybe something like that. So you should, if you are in a proper project development, then you would want to define this problem and constraints properly. Yeah, but for your project in class, I don't think we really require you to be so specific like that. Yeah. So in the first phase, this is what you should do. Yeah, analyze the situation, define what are the problems, what are the objectives. So what is the objective that the company wants right now? The organization, what does it want? To be able to what? All right, so that objective would help you to focus on what data that you want to keep. You know, what data you want to include in your database. See? And then what is the scope and the boundary? Like I said, when you go to an organization, there is a lot of things that you can do. Example, if you go to school, right? There are so many things that the school wants to keep information on. They want to keep information on how the students perform. They also may want to keep information on how does the teacher perform. All right. And then how does the finance situation of the school? How is the library operation? So there's a lot of things. So when you do your database, you need to be able to scope which one are you doing. You can't do everything, right? You can't do everything. Or even if you are in real life and you want to do everything, you still need to be specific on what you're going to do. Yeah. So that is the meaning of scope. So in your case, especially for your project, you need to scope. Like even if you say I'm going to go and do a project on a clinic. Even on a clinic, it's not just necessary just patient and doctor, but there are also other information, maybe in terms of pharmacy, and then in terms of the stock of the medication. Who is the supplier of the stock of the medication? What is the cost? So all this, are you going to include everything in your clinic database? So you need to scope it, right? So that is important. Okay, after you have done the initial study, you're going to go to the database design. So this is where you create your conceptual design. Okay, these are the things that you are required to do, and I think you have started to do. So after you have gotten all the information, you create the conceptual design. How do you create the conceptual design? This is where you start drawing your ER diagram, right? Okay, you start drawing your ER diagram. And then in the real world, you have to decide what DBMS you're going to use. And in your case also, you will have to start to think about what DBMS you're going to use. Again, the DBMS depends on what model you are using. Sometimes, in our case, we are going to use relational model, period, full stop. There's no question about it. But in real world, there are various models that you want to use. Maybe you want to use object-oriented. Maybe you want to use non-relational database. Yeah. So you will have to select a proper DBMS for that. Okay. Once you have once you have chosen the DBMS that you're going to use, then you're going to create the logical design. So, for example, in our case, we are going to use a relational database DBMS. So you're going to be using either Oracle or MySQL or some other relational database RDBMS. So you will have to look at the DBMS and see what are the requirements. This is where you start to create your logical design. So in our case, most of the time is relational, so you're going to be needing tables. So in your logical design, you will start to create tables. All right. And then your design also include creating the physical design. But in our case, we're not going to be doing this so much because most of the modern DBMS already takes care of the physical design part. Yeah, unless you have some special requirements, you usually don't need to basically look at the physical design. Okay, once you have done your design, then you start your implementation. This is where you actually install your DBMS. That means you start, if you with your laptop now, you will have to start installing your Oracle or installing your MySQL, right? And then you start creating the tables. Create the database, create the tables in the database. Okay, I'll just say this very quickly. When you download and install your database, let's say it's Oracle, or let's say it is MySQL, that is just the software, all right? When you open up Oracle or you open up MySQL, then you now have to create a database. In MySQL, if I'm not mistaken, creating a database is called creating a schema. Yeah, creating a schema. So a schema is what a database is called in MySQL. In Oracle, I can't remember. I think it's database. Okay, so once you have created a database, this is like you are creating a space. Then you start to create your tables inside your database. Okay, so you will have a database or a schema, and inside that database or the schema, this is where you will be creating your tables. Okay, so at this point right here, okay, after you have installed the DBMS, you create a database. In this case, you will create only one database because you only have one project, and then you start to create your tables. Okay, and then once you have created the tables, then in the tables you have proper key and proper foreign keys. So the foreign keys will actually link your tables together. Okay, that is why you need to properly create your foreign key, because when you create the database, you don't actually graphically drag or join two tables together. There is no such thing like you click on this table and drag to another table. No, you don't really do that. Basically, the foreign key is what link the two tables together. So the software understands that table A is connected to table B because there is a foreign key that connects these two. All right, so that's the function of your primary key and foreign key. So this is what you do at this stage right here. Okay, so after you have done that, then you start to load your data, right? You start to load your data in, and then if you have problems loading your data somehow, that means that your design is not correct. Because if your design is correct, you will not have any problem loading your data in, populating your data, keying in your data, right? So that basically, when you start keying in your data, when you start loading your data, if you feel that when you come to a problem, the data cannot be saved, or the data there's an error, that means something is wrong with your design. Either your primary key is wrong, either your foreign key is wrong, or even the design of the entities of your tables is already wrong. All right, that's a very simple way to actually know whether you're doing it right or not. Okay, and then after that you go to the you go to the testing and the evaluation. All right. Okay, and then after you do your evaluation, and then you do your operation. Okay, and then after that you maintain and then the evolution of the database life cycle continues, meaning that periodically you will need to check whether you have any problem, whether there are new requirements that is needed by the company, whether you need to add more tables, whether you need to alter the tables, and so on. Yeah. Okay, so let's see. So we go back to this. When we go back to this, so at every phase, okay, this is what you need. This is what's required, right? So when you are at the initial study, this is what you will do. Yeah, I think same thing here, right? Yeah, I've talked about this just now. Okay, so you analyze the situation, define the problems, define objective, define scope and boundaries. Okay. Summary of activities in the database initial study. Okay, so what do you do? So you will look at the analysis of the company situation, look at the company's objective, what is the company's operation, what is the company structure, you define the problems, and then you come up with your specification. What is your objective as a database designer? What is the objective? What is the scope? What is the boundary? So this is the one that you are going to be giving us in your project, in your project report. Yeah. But like I said, this is don't spend too much time on here, because this is not a big part of your report. I personally, I think just write some understandable paragraph about this, but don't go too detailed on this, because what's important is basically what you are going to create at the end. Yeah. So the database design should support the company's operation and objective, and so most importantly is the data should be an element of the whole system. This is when I say the database is actually part of the information system. Yeah, so you need to basically try to imagine that there is an information system that is in conjunction with your database. So maybe that would help you to understand more about what's going to be included in your database design. Okay, what's this? All right. So there is two view of data here. One is from the business point of view, and the other is from the database point of view. Okay, so from the business point of view, okay, they will ask, they are more interested in, because they're not going to talk to you in terms of data. They will just say something like, okay, our problem is such and such, and how are we going to solve this problem? When the problem is when we want to make such decision, we don't have this information. Okay, so in order to make this decision, we need this kind of information. How do we get that information? That information we can get from this data. Maybe that data is not available now, so we have to start collecting the data. Okay, so these are what the manager is looking at. They are concerned about what is the decision that needs to be made, what is the information that they need, and you, from the designer's point of view, you're going to understand that, and then figure out what data is required, and then you have to think about, so now that we need that data, how are we going to structure that data? How can we access that data? Is it going to come from a form? Is it going to come from I don't know, scanner? And then how are the data going to be transformed into information? So this is from the designer point of view, not necessarily just the database designer, but also the systems designer. So if you're talking about, if you're sitting with the person who is developing the system, then you have to, both of you will have to understand, okay, so how are we going to get this data? Do we create a form to create the data, to collect the data, or do we use the QR code? So if the systems designers say, yes, we are going to use a QR code because that is easier. So now you as a database designer, you have to figure out, okay, from that QR code, how are you going to make it go into this table? How are you going to transform? How are you going to make that go into the table that you are going to design? So these are the things that we need to ask when you are, developing the database and the system. Okay, so the database design process will start with the conceptual design, which you are already we have shown you how conceptual design is like, and then now you are on the verge of doing this, right? Mapping the conceptual design or the conceptual model to logical model components. So now I believe you should already be able to draw your ER diagram, and then that ER diagram will be transformed into tables, right? Into tables. Okay, later on next week we're going to look at normalization. This is another process in the design that would help you to ensure that your table are properly designed and do not have too much redundancy. Okay, and then you need also to check on your integrity constraints. Remember referential integrity and entity integrity. Okay, you need to look at that, and then you need to validate your model against your user requirements. And then you do the physical design, define the data storage, and so on. At this point, our class is not going to touch on this. Yeah, when you talk about performance measures and so on, this is usually taken up in a more advanced class. So we will just basically stop up to here, and then you are going to implement your design. So implementation, okay, as I mentioned just now, install the database, and then you create logical representation of your computing resources. And then you create your databases, and then you load your data. Okay. In the testing factors, okay, basically, when you are in real life, when you have your database, you of course need to check that your database is secure. Not only physically secure, it also has to be secure in terms of password security. You talk about physical security, I don't know, I think in system design, because you have to ensure that your database is in a secure site, physically secure from what do you call a disaster, yeah. And then you have to talk about, you have to look at access rights. When you have users accessing your database, you want to ensure that only the authorized people access your data. That is why you have your login and password. And then if you're doing a proper design and implementation, then you have to specify that, okay, if you have this user can only access this part of the data, only this table, or only this this section of the data. Other users may be able to access other parts. For example, a good example would be, if you have a system at everybody is using the same database, the lecturer have the rights to enter marks and look at the marks, but students do not have rights to the marks. You only have rights to look at the grades, right? And even then, you can only look at the grades and you cannot change the grade. Okay, so those are what access rights means. Yeah, so you in a real database design, you need to actually do this. This comes under the database administrator's job. Yeah, which is not included in this class. You are only here until the design and the implementation of the design. That's it. Yeah, and then you also have to do audit trail, ensuring that you know what data is being what data is being added to your database, any deletion to the data, who deleted it. This has to be properly logged, properly noted by the DBMS. Okay, and then you have in your testing, you need to actually check that all these are being done correctly. Because all this security, password security, access rights, audit trails, these are all available made available by the DBMS. The DBMS already has functions to keep the audit trail. But in your testing, when you're actually doing testing, you need to actually check whether these audit trails are actually being kept properly. And you also have to check on the encryption and then on the workstation optimization and so on. Okay, like I said, these are not in your project, but this is something that you should know if you are actually going to be involved in a database project. It just doesn't stop at implementing, but you also need to do testings, and these are some of the factors that need to be tested on. Okay, and once you get to the implementation, you need to ensure that database needs to be backed up. right? You have to do backup. So there are various types of database backup. You do a full backup, or sometimes it's called dump. That means you dump everything. All the database object, meaning that every single thing in the database is being backed up. It's the whole thing somewhere. Yeah. Or there is differential backup. Only the updated or modified objects since your last backup will be backed up. So you don't back up everything, because when you back up everything, imagine if your database size is, I don't know, 10 gig, for example. So the whole 10 gig needs to be backed up. But if you do differential backup, you only back up the difference, whatever is modified or updated. Or and you should also do a transaction log backup, because this, what it does is it does not only this transaction log is actually the audit trail just now. Okay, so it backs up the audit trail. Okay, and then so that you know what has happened since the last backup till now. So why do you do backup? Because if the database crashed, you need to be able to restore it. So when you have these proper backups, then if it crashed, then you will have your previous backup. You call in your previous backup, and then you can see what transaction has happened since then, and then that can be added back to your database. Yeah, and then of course database backups are provided with high security, because if you don't have high security, then people can tamper with your database. Okay. These are sources of how can database fail. Okay, database can fail because of software failure, hardware failure. Software failure can be, your OS is not working, or it doesn't boot up, or things like that. Yeah, hardware, or your hardware crash. Programming assumption is the program itself. Let's say, like I said just now, each database should come with an information system, meaning that there are programs that call the database, right? And then maybe in the program you did not take care of the conditions well, any kind of exemptions, yeah, and any kind of problem. Maybe you are looking for something is not there, and then you don't have any if you have an if-else statement, for example, that condition is not met, and then you don't have any else to that, and then suddenly the program doesn't know what to do, so the program fails. So that can be a cause of a failure to your database. A transaction can be lost transaction. It can be when you have concurrent transaction, for example, you have a lost transaction, you have a locked situation, and then other cases would be external factors, All right. Periodic maintenance activities. So once you get to the implementation, after you implement your database is going to be used. It's going to be used by your users, and then so you need to maintain your database periodically. So the main maintenance you do is your backup, which is preventive maintenance, meaning that you maintain your database, you do a backup so that you prevent any possible problem from happening. Yeah. Corrective maintenance, one example would be recovery. So once the database crash, then you recover the database that is correcting the problem that has happened. Hold on. And then adaptive maintenance is, cepat sikit. And adaptive maintenance is you are going to adapt your database to the new requirements. Okay, so this would involve making changes, making additions to your database. Other maintenance activities include assignment of access permission and their maintenance for new and old users. So this is maintenance that you need to do in terms of allowing people, new users, or if you have users who are no longer, so you have to remove their rights, their access permission, so things like that. General statistics. This is to check for the to measure the performance of the database. Okay, so periodically there is this facility by the DBMS which allows you to actually check the statistics on how the database is performing. Okay, so you need to actually generate those so that you will know how it is performing, and then how that would change how you need to edit your database. And then of course you need to do audit, security audit, and see whether there are any what do you call, pencerobohan apa? Ceroboh, people hacking into your database and doing unauthorized transaction on it. Okay, and then periodic system usage summary. The system usage summary is also something like statistics, whereby you get summaries on maybe who is using your database, which area that they're using, which time that your database is most peak, things like that. Yeah, how the usage of the summary. So all this are to allow you to understand how the database is being used and how you can help to, if there are any maybe there are at certain time the usage of the database is so high that how are you going to help to resolve that situation. Okay, so these are your maintenance activities that needs to be done. Okay, so as I mentioned just now, the database usually comes with an information system. All right, there is no such thing as the database just exists by itself. So it has to come with the information system. So this is to show you the parallel activities that happens in a database lifecycle and a system development lifecycle. So as you can see, you start with study or analysis, and then you do the design, and then you do the implementation. In the SDLC, it's called coding. And then you have the testing and evaluation. Once the test is okay, then you go into operation, and then you start your maintenance. Yeah. All right. So when you're talking about conceptual design, okay, this is where you draw out your design with ER. So you have your main data entities, then you have your attributes, your relationship, and constraints. People always again and again stress that when you do your conceptual design, it is hardware and software independent. You don't really think about what software you're going to be using, what hardware you're going to be using. So that's what it's meant by software and hardware independent. So you draw the design as per how the user understands it and how you are going to and what are the data that is what are the data that is required, or what are the data that is involved. And the mantra here is that all that is needed is there, and all that is there is needed. Can you understand that? All that is needed is there in your database. That means you cannot have a database whereby, how come we don't have that data? That data is not included. No, there's no such thing. All that is needed is there. And all that is there is needed. You don't want you don't want to have all kinds of data inside there, and then some of them is not needed by the organization. Example. Let's say you are designing a database about let's say about your customer at your, I don't know, shop, at your retail no, at your restaurant. Yeah, you're designing that database at your restaurant. So you have your data about customer. So you have the name of the customer, you have the address of the customer, the telephone number of the customer. Do you really need the height of the customer? You don't need, right? You can put the data there, but then all that is, then that means you don't fulfill this rule, because the data that is there, height is not needed. Why do you want to put it there? You are just going to waste your space on your database. Okay, so only include what is needed. That means all that is needed, or sorry, all that is there is needed. Don't put things that are not needed. Okay, and let's say when you are and for example, there's the same, the customer. You have the customer name, you have the customer address, you don't have the customer phone. You know, so then you might have a problem whereby you may want to contact the customer and the data is not there, so you don't fulfill this. All that is needed is there. Okay, so this is a very important rule. All that is needed is there, and all that is there is needed, especially this one. Yeah, sometimes you put data that is not needed. So make sure all data that is in your database are data that is required, data that is needed by the organization. Okay, conceptual design steps. We have done this basically in your ER modeling, so I'm not going to talk about this too much. Just that I want to, I just want to mention that we don't talk about it in this course, because it is a totally different design. But you should understand that centralized database, which we are doing right now, is not the only design available. There is something which is called the distributed database design. Distributed database design means you are actually looking at one whole set of data, but they are not locally put in this, they are not placed in the same site. So in the physical site, you may have some data in different parts. It can be in different parts of the network, or it can be different parts geographically. So you can have a distributed database whereby it is one located in faculty science, some parts of the database is located in PTM, some parts of the database is located in science computer. But you can also have a database where parts of it is in US, some of it is in Asia, some of it is in Australia. So that is its distributed database design, and how you design that is a whole different story. Yeah, you can design it according to the operation. You can design it according to locality. Operation meaning we will keep data regarding sales in America, and we will keep data regarding customer service in Asia, for example. Or it can be distributed in a way where we will keep all the data regarding US customers in US. We will keep all the data about Asian customer in Asia. So there are different ways to distribute your database. Yeah, so that is a different story altogether. But just want you to know that is distributed database design. Not all database needs to be in the same centralized location. Yeah. Okay, so when you're doing your report or on your analysis, you want to describe your operation. This is where you provide precise, up-to-date, and reviewed description of activities defining operations, operating environment. So this is part of your business rules. Yeah. Okay. Where does that come from? Anyway, never mind. Okay, developing the conceptual model using ER diagram. Okay, again, I'm not going to go through this too much because you have done that, right? You know that you need to identify your business rules, right? And then identify your main entities, and then define the relationship among the entities, define the attributes, define the attributes, the primary keys, the foreign keys for each entities. And then this is the part that we have not done yet, normalization, which we will be talking about next week. And then you complete the initial ER diagram. Okay, some of you might ask, if we have not done normalization, how can we have the complete ER diagram? Okay, basically you can. If you basically you can, because normalize for simple projects, you don't really you won't really have situation whereby your entities needs to be normalized. Yeah, because it's because the project is already simple enough whereby you can actually identify your entities quite correctly. Yeah, quite correctly. We will talk about it later in the slides. Okay. So you validate your ER and then you modify your ER if you have to. Okay. So basically same thing, you just initial study, you get your views, business rules, and then you do your initial model, then you get your attributes, and then you normalize if you need to normalize. Otherwise, normalize in this situation happens as a verification process. That means you want to verify that all your tables are already ready to be implemented. If you want to use the word that is used in the normalization jargon, you want to verify that your tables are already in the third normal form. Okay, but we will look at that next week. But that's what normalization do. Okay. All right. So basically, same thing. Business rules. Okay. In your information system, you will have your business rules, and then you have your data flow diagram, right? And then you have functional description. Right? This is all for your information system, and then you get all this information. In our part, we will just have this, right? We will only have this, and then you get and then you do your ER diagram, because we don't have this, right? Because we are not designing an information system together with our database, so we don't have this. Okay, we don't have this, but we have this. So we base on this, and then we get this. That's why I said maybe it's a little bit challenging for you, because we don't have this. Yeah, we don't have data flow diagram. We don't have functional descriptions. So maybe you get a little bit lost, but you will have to try to figure out if you have this data, what happens to the data actually, who uses this data, you have to basically try to understand the whole process, and then maybe that would help with your ER diagram. So you do your ER diagram, and then you can get your ERD. Normalization is one of the tools in there. Yeah, it can be used. It can be used as a verification tool, or it can also be used to actually come up with your entity. Again, this sounds confusing, but later on next week you will find it making more sense. Yeah, and then you will have your ERD, and then after you have done your definition and validation, you're going to get your data dictionary. This is where you will have your tables, you will know what are the attributes for the tables, what are the primary key, what are the foreign key, and so on. Okay, so verification, you need to, well, if you have a system process, then you need to verify that your data are those that are needed by the system, that the system functions. And then you need to look at your original design and then see whether your entities are actually complete from the design that you have made. And then look at the attributes. Okay, look at the attributes, whether the attributes are actually collecting or keeping the information that you want. And then so basically, again, if you are doing this in real life, what can you do to help you with the verification is actually look at a module in your information system. See, when you develop information system, you will have modules, right? Modules. What is a module in an information system? When you have, let's say, an information system on Maya, for example, you are registering for your courses, right? So that is a module, registration module. So when you are doing a registration module, what do you do? Then you look at the process. In a registration module, you will have the student information, and then they key in their information, and then they key in the course code, and then the course code would need to have when you register for a course, you need to know the system need to know what is the credit hour, so that they can calculate and compile how many credit hours you have taken, because you cannot take more than 21 credit hours. And then if you are under probation, you cannot take more than 15 credit hours. So this is the module in the information system. So can you see the difference? In the information system component, you will need things like, if you are under probation, your credit hours cannot be more than 15. If you are not under probation, your credit hours can be up to 21. Okay, so that is in your information system module. In the database side, what you need to do is, when student register, you need to keep not only the course code, but also the credit hours need to be, that data need to be available in your database. So this is where you verify that the data that is required in the module is already in your database. Okay. Okay. So these are some of the things that you need to do. Identify the ER model's entity, identify each module and its component. Okay. So this is the module in the IS, but since you don't have an IS information system, so this is difficult for you to do here. You don't have to, so you don't have this, but this is, like I said, if you're doing the actual database project together with the information system development, so you need to do this. Okay, and then you need to what are the updates that the module wants to do, what are the inserts, what are the deletes, what are the queries, the report, and so on. All right. Okay, so where is it that we say ER model is iterative? Okay, so you have this components, you define the steps, and then when you verify the model, if the model requires changes, then you have to make a change and verify it again. So this goes on until you are quite certain that you don't have any more changes. Then you have your final ER model, your verified ER model. Okay. Cohesivity and module coupling. Cohesive, strength of the relationship among the module entities. Okay, I actually forgot what this is. Hold on. Module coupling, extent to which modules are independent on which other. Let me double check on this, yeah. I don't know whether Dr. Jihan, can you explain this? I kind of forgot what this means. I mean, I know it has to be cohesive and coupled, but I don't know how to explain it to you. I will get back to you on this. Yeah. Yes,
Me too,
Dr.
Dr.
Jihan.
Fariza. I'm not really understand this.
Yeah, that's what I said. I will have to find out basically how to explain this. I mean, we know this secara intrinsic, we know.
Yes,
by
but
experience, we know.
how to explain it?
Explain to you.
It is
Okay.
difficult.
Yeah. Let me just get back to you on this line later. Maybe during tutorial. Maybe I'll put in a new video or whatever to explain this. Yeah, later. Okay. Distribute database design. This is where I said just now. There is not just centralized database, but also distributed database, whereby portions of database may reside in different physical location. Okay, subset of database stored in different location. So the database is the same. It's like the whole data that is going to be used by that organization, but you may want to keep it differently. You might want to keep it at different sites for certain reasons. Yeah, for certain reasons. Sometimes it's to ensure security, performance. For example, performance. One example I can think of is this. Let's say you are developing a database for a multinational company. Okay, so this multinational company, let's say most of the users are in Australia. All right, most of the users in Australia, and they have some. Let's say we're talking about, I don't know, maybe what do you call? Maybe this is a company that does a lot of research on North and South Pole, for example. Yeah, maybe North and South Pole. So all the research from the South Pole are all being based in Australia, because Australia is the closest to the South Pole. And then you have some in Alaska on the North Pole. Yeah. So in order for performance, since a majority of the data and the users are in the South Pole in Australia, so they will probably want to keep that part of that database in Australia. Because if you put it in Alaska, the performance is going to be it's going to be a little bit lower, because there is so much, traffic having to go from one end to the other, right? So maybe because of performance, they do it that way, or security or whatever, or maybe security. Let's say your very, very important data you want to keep in a location where that is not earthquake prone. Yes, so you don't want to keep your data, your most important data in earthquake region. So you want to keep it elsewhere. So that could be a reason where you want to do a distributed database. So a lot of this, yeah. Okay. One part of the database DB lifecycle, DBLC, is choosing your DBMS. So how do you choose what DBMS to use? Like I said, one, you depend on your model, right? So in this case, our model is relational. So we have to choose based on relational database. And relational database, you have more than one, right? So what would affect you to choose? One, you might look at the cost. One, you might look at the features and the tools available. One, you might look at the portability. And one, you might look at the hardware requirements. Yeah? Okay. Logical and physical design. All right. Like I said, logical design is when you already have your conceptual design and you want to translate it into your database. Okay. But it is independent of physical level. So you don't really care about where the data is going to be kept, which buffer, what size buffer. You don't care about that. You only care that this is a relational model. So we are going to create tables. All right. And then tables, again, you can use normalization to validate it, to make sure that your tables are all in third normal form. And then you look at your integrity constraint, whether it is referential, whether your referential integrity is okay, whether your entity integrity is okay. And then you check it against your user requirements. And then, of course, you have your physical design, which look at the data storage organization and data access characteristics. Okay, again, this talks about the same thing. I'm not going to go through that, blah, blah, blah. Okay, this is for your physical design. You want to determine how are you going to keep your data. Are you going to put related tables adjacent on what blocks of the disk? Okay, so again, like I said, in this class, we don't talk about this because this is basically already been taken care by your DBMS, unless you have special requirements in which you have maybe, you have special requirements. That means you need to go into the database, into the DBMS, the DBMS administrative part, and then do this. Yeah. All right. Again, database roles set the privileges to units of user or group of users. Okay, this is also done by the DBA, database administrator. So when you are doing your database DBLC, database lifecycle, this is part of the lifecycle, right? When you do your implementation, before you implement, you need to do all this stuff. Okay. Okay, just go back here. In your project, in this class, you don't do database administration. Yeah, so when you design your database, it's basically everybody can use your data, can use your database. Yeah, because we don't go into this. This is only taken care when you go into database administration. All right. Okay, this we need to understand. Top down and bottom up. All right. What you have been taught so far, what you look at your business rules, right? You look at your business rules, and then from your business rule, you build your conceptual model. What do you have in your conceptual model? You will start with entities, correct? You will start with entities. When you have each of your entities, you will look at what are the attributes in each of the entity. Okay, so this is actually a top-down design. A top-down design. Okay, so you basically have your conceptual model whereby you start with drawing your entity, and then for each entity you look at what are the attributes within that entity. Okay, another way of doing design is a bottom-up. A bottom-up is when you start with looking at the attributes of the organization's data. So you have attributes. Where do you get attributes from? One place that you can look at attributes is from the form that the organization use. Registration form, claim form, I don't know what forms, whatever, all kinds of forms. Invoices is actually another form. Sale order is also another form. Purchase order is also a form. Your appointment card is also a form, meaning that there is, your appointment card is also a form. What can you get from your appointment card? you have your name, you have your reference number, you have the date, you have the appointment, time, and then you have the clinic that you have the appointment with, the doctor that you have the appointment with. So that is also a form. From that, you will get all your attributes. Okay, so when you have all these attributes, you can actually start to group those attributes into entities. So this is bottom up. You start with attribute, and then from the attribute you create entities, because you group your attributes into certain entities. And the best way to do the bottom up is using normalization. Okay, just now I mentioned that normalization can be used to verify your model, your entity. That means you already have your table. You do your normalization to verify that your entity is already in the third normal form. Okay, try to remember this. If you do a top-down, you use normalization to verify that your entity is already in the third normal form. Okay, if you're doing a bottom up, you will have attributes, and these attributes you will do normalization process, in which the end result of the process would be entities for your model. All right, so normalization is quite unique in a way that you do normalization to verify your top-down design, or you do your normalization as a process for your bottom-up design. Okay. All right. So another thing about database design is whether you are doing a centralized design or a decentralized design. Okay. So in your case, because yours is a very simple project, you are doing a centralized design, whereby you just look at the whole system. You just look at the whole system. What is the system user view? What is the system processes, even though you don't have system processes? What is the data constraint? And then you come up with the conceptual model, right? And then from there, from your conceptual model, you do your logical design, you get your data dictionary, whereby you have your tables and you have your attributes. Centralized design. Decentralized design is when you have a very large project, for an organization, right? Whereby there are many different areas that you want to cover. Yeah. For example, in this organization, you are going to cover not just the purchasing. When you talk about purchasing, you're talking about looking at the purchase order, looking at the logistic, looking at the delivery order, looking at the sales, looking at the supplier. Yeah. You need to also look at the manufacturing. And then you need to look at the engineering. So these are various different areas of that organization. So usually you cannot look at it all together at one go. So you need to look at separate models. They're separate models. So you look at manufacturing, and then you will get some kind of understanding. You will get your model. Not the complete model yet, but you have your own. You will understand, okay, these are the entities that you're going to need, these are the entities that you will have. Same thing with the purchasing. And then another group will look at purchasing. The purchasing will also come up with their own entities, and then the person who look at engineering will also have their own understanding of that process and come up with some kind of entities. And then you will have to do an aggregation. Then you will see, okay, this group also have, let's say, a product a product entity. This person also group has a product entity. Then you try to aggregate that entity, and then at the end you will have a conceptual model, and then you will have a data dictionary. So in your case, you will probably be doing a centralized design because you're looking at the whole thing and then you come up with your entities. But if you're looking at separate modules, yeah, let's say you're going to a school, and then, like I said just now, maybe one group is looking at students' performance, the other one is looking at teachers' performance, the other one is looking at costing for the school. In all these three different areas, maybe teacher entity is common, because when you talk about teachers' performance, of course you will have an entity about teacher. When you talk about students' performance, you also probably have an teacher entity, because teacher teaches classes, and students takes classes. So that is also in that particular module. So teacher is in the teacher performance group. Teacher entity is also in the students performance group. In the costing, you also probably have a teacher entity, because you need to keep track of the spending of the teacher. Maybe the teacher goes, one is the teacher's salary, two is the teachers going for course, and maybe for courses to learn new things, and then maybe the school has to pay for it. So that is included in the cost of the courses. Costs of the courses. So the costing for the school also include a teacher entity. So now all those need to be aggregated, yeah, and then you come up with the conceptual model. All right. Okay, so when you have aggregation, you will have a problem whereby two departments may use different names for the same entity. Okay, remember just now teacher for the teacher's performance, teacher in the student's performance. All right. So when group A comes up with the entity teacher, maybe they call teacher ID as teacher ID. But in the students' performance group, the teacher entity, the ID is maybe given as teacher number. So you will have different labels used, different labels or different names used for the same entity. So you need to aggregate that. So you need to determine which one are you going to use. Right? So when you change something, so all the other entities that has relation to the teacher entity will have to change all their labels too. So that is a problem that you need to look at. Yeah, you need to address that. You might miss something, and then later on when you build your database, you will find that it doesn't the group, the entities doesn't connect well. Yeah, so you need to double check that. Okay, so those are called synonyms. Yes, synonyms. That means two different names are being used for the same thing. Okay, for the same thing. Synonyms. Homonyms is two different entities are addressed by the same label. Okay. All right. Just now when I give you the example for synonym, I am using the attribute. But actually it can also be at the entity level. Okay, maybe you have I don't know. Okay, maybe for that school, in the teacher's module, the teacher entity is called teacher, but maybe in the student's performance module, the entity for teacher is not called teacher, but maybe it's called instructor. So synonym. different names using for the same entity. Yeah, teacher, instructor, same thing, but this one is called teacher, this one is called instructor. So that is also another example of synonym at the entity level. The one I gave to you earlier is at the attribute level. Okay, homonyms, two different entities are addressed by the same label. So for example, for example, let's say you another person, another group, also looking at a school database. Yeah. Let's say the teachers are called instructor. Okay, the teacher are called instructor, and then in the students' performance, okay, in the students' performance, maybe the group has two different things. One, they call teacher for teacher who teaches classes, but they also have people who actually teaches teaches certain projects. Maybe they have a school project, and the school project is being led by someone, and they call that person instructors. Okay, so now you have the term instructors using one by the group A to identify teachers, but in the group B, instructors is being used, the name instructor is being used to identify a different set of people who actually help with projects, who may not be teachers, who may be parents. Yeah, so they call these people instructors, but the term instructors now is being used for different things, for different entities. So that is homonyms. All right. What is this? And then there are other problems. Let me see. Again, this is where you will have okay. In our design, we have not really talked about subclass. Okay, we have not really talked about subclass. This is an advanced. We call it extended ER, which we do not look at. But what it does is it has the same concept as hereditary. If you remember object oriented, it has a concept of hereditary, whereby if you look at this example right here, an employee is the main thing, right? An employee will have name, address, phone, and an employee can be actually further broken up into secretary. Sorry, it can be my battery running low. So okay, secretary can be employee can be broken up into groups of secretary, groups of pilot. So if you see here, so secretary will have name, address, and phone. It will inherit those, and also have other attributes such as typing speed and classification. Pilot will also inherit name, address, phone from employee, but they will have other attributes such as hours flown and license. So when you do aggregation, you might want to see whether the other groups are actually having subclasses or not, and then whether you are actually inheriting from the correct entity or not. Yeah, so you need to look at that. In your case, you don't have this problem because we don't do subclass. And then what? Conflicting object definition. Okay, so this is almost the same like the one I mentioned just now, whereby in this particular group, the professor primary key is Professor SSN. SSN is Social Security number, which is in United States. So in our case, we will say Professor IC, right? Professor IC. But for this department, they use the professor number. So again, this is conflicting. So you need to, when you do aggregation, you want to ensure that you don't have conflicting information. You don't have conflicting structure for your entities and your attributes. Yeah. So which in your case you will not have a problem because you are doing a conceptual. So you are doing a centralized design. You are not doing decentralized design. So you should not have any aggregation problem. But just for the sake of knowledge and for the sake of exam or test, so you may want to understand what is aggregation problem, which arise from decentralized decentralized design. Okay, that's it. Finish. Okay, all right. So we finish the lecture. Okay, so now I think we should go to you and what do you want to ask about your project? Because I have a lot of people asking question about the project, and then maybe you want to ask here so that everybody else will get the same answer. Anyone?
Doctor,
Yeah.
I just want to ask if our ERD has been normalized. What are we supposed to put in the normalization section?
Now you just say that all your tables have been normalized to the third normal form. We will look at normalization next week, and then so for many cases in database design, in many cases for daily use, that tables need to be at the third normal form. So we will find out what is third normal form, and you have to, for once you have done your tables, you need to go through every table and look and verify that each table is in the third normal form, and you just need to verify that. Just say that. If it's not, and then you just say, oh, this table, when we first design it, was in second normal form. Now we are after normalizing it. Now it is in the third normal form. So sometimes, like I said, if you are doing it properly, maybe at one go all your tables will be in the third normal form. So you don't have to do any additional normalization process. But if you're not doing it correctly, when you go through each table, then you will say, this one is not in the third normal form yet. So you will have to normalize it to the third normal form. Okay. Any question? I have somebody asking me, is it okay to have one table which sits by itself and does not have any link to other entities? So that is not proper. I mean, if you think about it, yes, it could happen, but why is it not related? Why is it linking to other entities in your ER? What that means is that entity that is standalone, that means it is from a different scope. It is not within the scope of what you are looking at. Because if it is in the same scope,
Dr. Fariza, are you still there? Okay, we wait for Dr. Fariza to come back. I think there must be something wrong with her connection. Okay, class, have you started your group project? So if you you have gone through all the slides prepared by Dr. Fariza, then I think you should have some initial or some ideas how to proceed with your project. Okay, so you can start design or identify your attributes, and then also your entities. Okay, and then also the relationship among the entities. Okay, then you can design your conceptual for the time being. Okay, so Dr. Fariza is in now, so you can continue, Dr. Fariza.
Apa dia? What happened? Okay. Anyway, what were we talking about? Sorry, I don't know what happened. Okay. Anyway, what was I talking about? Alamak, tak ingat dah. Okay lah, tak apa. Continue. Next question, please. Oh, okay. About the entity that is standalone. Yeah. So if it is standing alone, that means it is not part of your scope. Okay, so you can just remove it. Okay.
Doctor, I have 3 questions. First, can we send? I already did the ER diagram, and I already did the database design using the Heidi SQL. And then can I check up on you? I mean to send our group ER diagram for you to check.
Okay. You said if you have to. Okay. What? Okay. This is what happens. Yeah. A lot of okay. I know some students, when they work on the ER, they work on their own. So they draw on their own, and then they, what I want you to do is, before you send to any of your lecturers within your tutorial group, what I would encourage you to do is, each member draw your own ER from the same information. Each member draw, and then you show each other, this is what I come up with, this is what I come up with. Then you discuss why are you doing it like this and not like this. Okay, then if you still not satisfied, then you send to us. All right, because otherwise, if you send to me, you know what happens? I will fix it, and then you don't think, and then you just take whatever I give to you, and then you just say, okay, so you're not learning anything. So the best way is, each of you do your own ER, and then you show each other, and then somebody will draw it like this, somebody will draw it like this, and then you will say, okay, why are you doing it like that? Discuss why. And then by that time, if you really need to send to us, you send to us. Then then at that time, we will have you will actually have thought about it a little bit, instead of just sending to me, and then I will just say, oh, this is not correct here, and then I will say this should be like this, and then you're not doing anything, you're not learning anything. Okay, fair kan?
Fair. But Doctor, we did the ER diagram together using the Lucid app. I mean, our group member has contribute into the one ER diagram. So just not make sure our work is on the correct path.
Okay. You can send, but like I said, I'm not going to fix it too much. I will just say something is that's not right. Just fix it. But I don't think I want to go into too much detail, because otherwise it's not fair. You will, but again, like I said, to somebody, also to some students, if you design it, and if when you try to, and if you want to, you don't have to, you don't have to straight away do it, implement it on your PC. But what you can do is, okay, now that you say, okay, now we have like 6 tables or 8 tables because you have 8 entities, right? So try to populate some data into those tables. If you cannot populate the data correctly, something is wrong with your design. Okay, so do that first, and then if you have to, yes, of course you can send to us. But like I said, I'm not going to be telling you what is correct and what is wrong. You know, you will have to. I would just say, yeah, something is not right. You know, try. You know, maybe think about this area. That's about it. That's about what I will do. Yeah, but like easy, if you're not able to enter the data correctly, properly, that means maybe you have to repeat this data a few times, or maybe this data doesn't go in correctly, then something is wrong with your design. Yeah, of course you can, but I will not give too much correction on it lah. Okay? If you have discussed with your members, then yeah, we will know lah if it's a group work or whether it's just one person doing the job. But of course, yes, of course you can send.
Second question, I would like to ask you for explanation because I forget about we don't have the final yet, right? Because we have the summative assessment kan. For the poster, is it the information about the poster will post later on?
Yes, I think I can't remember what week, but it will be
week 9, Dr. Fiza.
Week 9?
Yes, week 9.
Okay, so week 9 we will give you information about poster. Usually when we ask you alternative assignment like this, the poster you'll be given more than a few hours lah kan. Berapa lama kita bagi Dr. Jihan? I can't remember. One day.
One day.
One day, you know. So you should have enough time to basically, because it is not something like right or wrong. You know, it is something. It's not like you have to you have to implement, you know, the right ER diagram or something. But it's something like you have to be creative. You need to be able to explain. You need to be able to explain that you understand the concept. You know, you understand what database design is all about. You know, that's basically what the poster is about lah. It's not like draw this. It's not like you are given. It's not like exam. You know, exam when you are given like this scenario, and then you have to draw the ER diagram based on that scenario. No, this is something a little bit more apa orang kata flexi. You know, because if we give you a particular scenario and you have to draw an ER diagram, then usually the answer is quite standard, right? That's how the ER diagram should look like. But this one is flexi because you need to be creative. You need to be able to explain well. Maybe you have to draw an ER diagram, but you know, it doesn't have to be perfect. You know, it doesn't have to be macam if you're worried about, I'm not so good at ER, you know, but we are not testing you on that, but we are testing on your understanding of the whole concept, something like that. Okay, so week 9, yeah, this is week 6. This is week 6, right?
Week 7.
7 already.
Last week week 6 we had midterm test.
7, 8, 9. Okay, week 9.
And for the test week, week 14, so we have a paper, right? For the
yeah. Week 14, yes, we have something like your test online.
Thank you, doctor.
So those of you yang internet not so good, so week 14 you will have to prepare yourself to get a good internet line somewhere for week 14. Yeah.
And last question itu for the I do the database on the clinic. So the clinic is like the small organization. So I cannot focus the into the something like financial or tu sebab dia just a small clinic. So I just take overall like medicine, patient.
Yes, of course. Yes, of course. That's why I said if you only need to scope if your organization has a wide operation, but otherwise you can just do everything. So that's okay. Scoping. So you can just mention that since the clinic is small and the operation is not very doesn't have that much operation. These are the things that they do. So you just cover everything. You just mention that in your scope. You just say you cover everything that the clinic requires.
Okay, thank you, Doctor.
Doctor, sorry, Doctor. Doctor, can I ask, can we have synonym in ERD diagram?
What do you mean synonym? Example?
Let's say I have two tables. The first one is student table. The second one is student account table. So for student table, the primary key is student ID. Then for account we have username and password.
Okay.
The username.
Okay. All right. When you see you're already having some problem with that, kan? You're trying to think, why student ID, student account. Why do you need two entities, student and student account? Is it one or is it one to many?
It's one to one.
I see. Whenever you have a one to one, you usually can join all the information in one table, because there is no point in trying to break it into another. If it is one to one, usually if it is a one to one, it is okay to just include everything in one table, unless let's say you have entity A and then you have entity B. This is one to one, okay, one to one. But entity B may have a relationship with entity C, which is maybe a one to many. So that's why you need to break this. Okay, but otherwise, if you don't have this entity linked to another entity, then you just put this one together. No need to break into two.
Sorry, Doctor. Sorry, I didn't make it clear that actually the relationship is optional one to one.
Optional one to one. It's okay. Okay, all right. Okay. Meaning that some student will not have account.
Yes.
Okay. All right. So that student account entity will also have the same primary key, is it?
Actually, it's primary for each key. Just that the label is different label. Because username, we use the student ID.
You have student and then you have student account. So student, a table you have student ID. Student account you have your primary
username.
Why? I still think, why don't you try to put it into one table? What do you mean optional? Meaning what? What is in the account table? What is in the account table?
So, Doctor, I talk about my project. So my project is focused on the school management system. But then only student who takes computer science course at secondary school, only that kind of student got computer account. Those who didn't take computer science didn't have computer account. So this is the problem.
Okay, computer account. So what are the attributes is in the account entity?
Three, the username, password, and the storage volume.
Okay. I would suggest try this. Yeah, I'm not sure. I would suggest you for your student account keep
Yes.
the key as okay. Okay, you have username. Username is synonym, meaning that the data is the same. Is it?
Yes.
The data is the same. Try to use the same. Try to use the same uh, key, the same name for the key. Try it and see what happens when you implement. And right now in your conceptual diagram, it's okay, you just put whatever. But when you implement it, try to use the name, student ID also, because it needs to connect. So I'm not sure whether the primary key can also act as a foreign key there. So
Okay.
use the same ID so that you can connect. Unless it gives you a problem, then try it another way. But I would just use the same student ID as the key for the account number. All right.
Okay. Thank you, Doctor.
Yeah, because if you use synonym, then you would have into a problem, I think, later. Right?
Thank you, Doctor.
Okay. Okay. Before I forget, there's one thing that I want to also remind you. Um, you will need to, because we cannot have lab, right? It's very difficult to have lab. I don't have my Oracle thing to actually show you, um, to demo to you. I do have my SQL, but even then, it's quite difficult to demo to you. So we are hoping that I think next week, or I think soon, Dr. Najihan will put in some links to information on how to download and use MySQL, and I will also, because the last semesters people have been using Oracle, so I will also add some information about Oracle if some of you wants to download Oracle and try to implement that. So you will have to do that as a group, learn together, right? Any problems, then maybe you can put to the group. Those of you who have actually tried using them may be able to help each other. Yeah, because it's very difficult to have lab right now. We cannot, so I'm hoping that you can do this basically within your group members. So that's why you have to have a good relationship within your group members, so that you will learn together. Maybe together, download. Each of you should download your own and then try out. Don't just let one person do it, and then learn together like that. Yeah. So next week tutorial, there won't be a face-to-face, but we want you to use that time to actually do your installation and so on. Yeah. I don't want to promise, because I have this old video I did on my SQL, but the video is so bad. Because that was my first attempt using my SQL after so long, because all this while I've been using Oracle, and then I tried using my SQL for the first time after like many years. So it was very bad, because they have a new interface for MySQL. They have Workbench now. So that was my first time using Workbench, and I was like trying to find out what was going on. If you want, I will put up that video, but it's really bad. It makes me look so bad, like I don't know what I'm doing. So but maybe I'll share it with you. Yeah, maybe I'll share it with you. But I don't have one on Oracle, because I don't have Oracle on my laptop. My Oracle is in the office, so it's very difficult to show you. So try to learn on your own. Yeah, anyway, you are all computer science students. You are all much more experienced in terms of using all these softwares better than me, I'm sure. So I trust that you will be able to download and actually work on your own on the installation and the DBMS, right? Any questions?
Good afternoon, doctor. May I ask that about the Oracle? Actually, we found that there is an online platform called Oracle Live SQL. Can we use that?
Does it allow you to have your own workspace and develop something?
Yeah, we can run our query there and create our schema and so on. Yeah.
Yeah, if it allows, if it gives you a space where you can actually create your own tables, and then it's okay.
Oh, all right. Thank you.
Because the one that the resource that I will be putting up on Spectrum is basically a standalone that you download onto your laptop, and then it takes up space on your laptop and then and stuff. So I don't want to do it on my laptop since I already have MySQL. By the way, can you share that link with us? The Oracle SQL site.
Yeah, sure.
Yeah, just put it on Team, I think, so that everybody can take a look. All right. Thank you.
Okay, I will share in the team.
All right. Thank you.
Doctor.
Yeah.
How would you rate the importance of learning the actual syntax of SQL? Because I'm not sure if you're aware, but I tried MySQL before, and yes, you say they have a new interface called MySQL Workbench, and it's incredibly oversimplified. When it comes to like creating schemas and also creating tables, I don't even have to type anything in the query. I can just tick something.
Yeah.
Do you think that's important?
Okay. Actually, we will look at SQL in week week 9, I think, Dr. Jihan, right? Because yes, now the DBMS, yes, they try to make it simple for you. You just click. You don't need to create your table using your SQL. But if you are writing program, okay, so if you are writing program and in your program, let's say you are writing a program, you are the programmer for information system development, right? So you are writing this PHP program or Java program. You need to insert SQL scripts inside your program so that whenever you want to write a query, you need to, or let's say you want to create a new table, then you will have to write the SQL create table SQL statement in your program. So this is when you actually need to know your SQL statements. So yeah, you will need to know that if you want to be a programmer. Otherwise you just click. You don't have to actually understand SQL that much. Yeah. So does that answer your question?
Yes. Thank you, Doctor.
Oh, by the way, when in your project, we will want you to write SQL statements for your query. Okay, so when we go to week 9, when we learn about SQL, then you need to select data from your database and stuff. You need to write out those SQL statements in your program. Yeah, you still need to do SQL. Maybe not for create tables, but for queries, you may have to still write SQL statements. Okay, you need to include that.
It is still very limited.
Yeah?
It is still very limited. I mean, creating tables sure can, but when it comes to inserting values or inserting rows, you still have to use the query lah. But it's just certain part of the.
If in Workbench you can actually insert straight away into the table, you can actually. But
I haven't explored that yet.
Yeah, but writing select statements, yes, you may have to still use SQL. So we will have SQL syntax in week 9. All right.
Okay, thank you, Doctor.
Any questions lagi? Anyone? Okay, so I really hope that your group are doing okay. If your group is still not doing okay, if you need to send a red flag to us, then do so. Yeah, send a red flag so we can help to to try to help you get together in your group. So one of the group actually, I think missing one member. I don't know. I hope that is resolved. I lupa nak follow up. One group, one of the member has not been contacting them, and that member does not even sit for the test. So I think he has probably dropped off from the course. That particular group, just update me again about. I forgot. I totally forgot to follow up with you. What happened? Yeah. Okay. Anything else, Dr. Jihan? Anything you want to say? Is Dr. Khalid here?
No.
Dr. Khalid ada tak? Okay. If not, so good luck. Work hard on your project. Yeah. Okay. Us. That's it. Anything? Okay. Bye.
So
Thank you.
we meet again next week, right? During lecture.
Yeah. Next.
Yes.
Next week normalization. Also another face-to-face. All right. Okay. Thank you.
Thank you, Dr. Fariza. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
All right. Bye.